And welcome to our channel. We are called Faster Learning Consulting. My name is Jaziri, and today I have a nice lesson, and it's on the normal patterns that you find on when you do calculation. So today, I was trying to observe some patterns, and I found one, and I want to share with you. So sit back and enjoy our lesson. So one pattern that was outstanding that I want to show you. You bear with me because I'm going to take some time to draw stuff, like a small table, and from there you will see. So there are some numbers that I identified. So these are numbers that that add up to 20. Okay, and then I'm also going to look at I'm also going to look at the distance. We're going to look at the distance of these numbers that I'm going to use from 10. Okay, and then say, so let me just make a small table. This, and then I'm going to look at the product of this. So we're going to look at the products, and then also the product differences, from 100. So we are going to look at the product differences from 100. And there's a small pattern here that's very interesting, and I think everyone should be in a position to know it. Okay, so what I found out was that every time you have, especially I focus on the numbers that add up to 10. So let's say my first number was 10 and 10. So 10 and 10 adds up to 20, like this one here. And then number two is 9. I reduce this one by 1 and I add 1 here. So this one becomes 11. Okay, so that's number two. Number three, let's have a look. So we have here 8 and here 12. And then we have here 4 and here we have 7. We reduce that one by 1 and we add here once we have 13. So maybe I don't know whether it should continue from before, but because you are going to see the pattern very soon. So let's have a look. And now we have 6 here and we have 14 here. And then we have here 6, we have here 5, and then we have here 15. So I think up to that level, from 6 samples, we should be able to get to see the pattern. Okay. Although the longer the examples, the longer we see the pattern, and the pattern is outstanding. But in this case now, if you see, like if you add 10 plus 10, it gives you 20. Now, I want us to multiply them because that is the principle here. 9 plus 11 gives you 20. 20 plus 12 gives you 20 plus 8 plus 12 gives you 20. 7 plus 13 gives you 20. 6 plus 14 gives you 20, and 5 plus 15 gives you 20. So that means if you add the two numbers, multiplier and multiplicand, then if you add them, like if you add the two, should give you 20, all of them. But if you multiply them so that you have the multiplier and the multiplicand, then the story changes. Then we have, so if we multiply 10, so assume now we multiply this, 10 multiplied by 10, product is 100. We multiply 9 and 11, we have 99. Multiply 8, multiply by 12, what we're having here is 96. Yeah? If we multiply then 7 and 13, so what we are going to have here is then 91. Yeah? 6 multiplied by 16, so if we multiply this one, we multiply this one. So assume we multiply them and not add, like I proposed. So 6 multiplied by 16 gives us here 84, and 15 multiplied by 5 gives us 75. So the assumption is that that's just like basic multiplication that someone can do, but there's more to this. So for example, why do I say there's more to this? Because now let's have a look at the pattern. So with what am I reducing these numbers? So especially I'm going to look at all these numbers in regards to 10 and also 11. So I'm just reducing. So the difference from this, the distance of the number we are multiplying from 10. So for example, I will use here 10. So the first one is 0. Second one from 10, 9, 10 minus 9, that one becomes 1. 8 minus 10 becomes 2. 7 minus 10 becomes 3. 6 minus 10 becomes 4. And 5 minus 10 becomes 5. Okay. Now, the funny or the most important thing that I want to share with you is then the pattern. Now you see what is happening. You see that the distance between these numbers are only giving you 1, 2, 3, 4, 5. And now let's have a look at the difference between that number to 100. Okay, to realize that 100 minus to our product, so we'll look at the product differences from 100, because 10 times 10 is equal to 100. So our main goal now is to look at what is 100 minus 99, where we have 100 minus 96, 100 minus 96, we have 4, 100 minus 91, we have 9, 100 minus 84, we have 16, 100 minus 75, we have 20. Okay. Now, this is what is very interesting. And why I say it's interesting is because, so here you have 100 minus 100 is 0. So you have same is 0. The thing is that the further you go, now you have this for one, for distance of this multipliers and multiplicand from 10, we have here 1, and here we have 1. In short, what I'm seeing here is that 1 squared gives you 1 here, 2 squared gives you then 4 here, 3 squared gives you then 9 here, 4 squared gives you 16 here, and 5 squared gives you 15 here. So what I observed was that if you take a number, let's say you want to add up the numbers up to 20, then you try to play with them. You have like 10 multiplied by 10, and then you reduce this one by 1 and add 1 to this side so that it's still 20. You realize that the distance between what the number you took here, like 10, as you try to reduce them and you get the products, the difference between the biggest number and the second one, the following number, it's almost like the square of what you had, the square of the difference between then 9, like the consecutive numbers like 10 and 9 and 8. And so you see here, it's just like the difference between 9 and 10 is 1. And if you square that one, it gives you 1. And if that's what you subtract from 100, you get 99. And that means that if you go to 3, there's a difference of 2. And that's 2, if you square it, gives you 4. That one already kind of gives you, if it gives you 4 there, then you just take that 4 and subtract it from 100 and you get 96. So you realize that if you take 4, subtract it from 100, you have 96. If you take 9, subtract it from 100, you have here 91. If you take a similar amount, again, if you take 16, so that's how they're connected. So 100 minus 25 gives you 75. You also see that, 10 minus 9, it gives you 1. And it is this one that you square and gives you then a clue of what's going on here. So this is an indication that I also find very important. I wanted to share with you because I know that when it comes to calculation, when it comes to maths, it's very essential to see the pattern, because like that, then your calculation becomes perfect, and your love for maths even grows. And that's why I wanted to share with you. So please, if you like this video, just share with your friends or with your brothers. And if you're a parent, share with your kids. And please subscribe to our channel, support us, and let's see each other on the next video. Thank you so much, and bye.